What really separates a good app from a truly great one? You know, it's often not the flashy features, but something much more fundamental. It's the ability for it to just work, no matter what your internet connection looks like. Today, we're going to dive into the architecture that makes all that happen.
Just think about it for a sec. You're on a subway, you're driving through a dead zone, or your Wi-Fi just decides to quit on you. What happens to the app you're using at that very moment? Well, for most of them, the answer? It isn't pretty.
And yeah, that's the simple, frustrating truth. The second that connection drops, the whole experience just shatters. You tap a button, and nothing? Maybe you get that dreaded loading spinner that just spins and spins and forever. It feels broken because, well, it is.
Or even worse, the content you were just looking at vanishes, replaced by some ugly error message. But think about some of the best apps you use every day. They don't have this problem at all. So how on earth do they do it?
Well, they do it by planning for that exact moment, the inevitable moment when the internet dies. They use a fundamentally different approach to building their software. This right here, this is the secret sauce, offline-first architecture. And the core idea? It's actually pretty simple, but it's super powerful. The app is designed to work first without any internet connection. It treats syncing with a server as a secondary task, something that just happens in the background whenever it can.
Okay, so what's really cool about this slide is how it shows you that shift. On the left, you've got the traditional app, and it's basically helpless, right? It asks the server for data, it waits, and then maybe it shows you something. But look at the right. In the offline-first model, the app talks to a database that's right there on your device, it shows you the UI instantly, and then it worries about syncing. It's a total flip of the script.
And look, this isn't some weird abstract theory. You literally use this stuff every single day. When you open WhatsApp on the subway to read old chats, or you pull up a saved area in Google Maps with zero signal, or you access your notes in Notion on a plane. Yep, that's offline first. The app just feels reliable because its core job doesn't depend on a live connection.
So, how does this magic actually work under the hood? Well, it's not really magic at all. It's just a really, really clever and robust architecture. So let's break down the anatomy of how these apps are actually put together. You know, it really just boils down to three critical pieces. First up, you've got a local database right there on your device, and that acts as the main source of truth. Second, there's a smart sync engine, which is kind of like the brain of the operation, managing all the data transfer in the background. And third, and this one's huge, you need a clear strategy for what to do when things get messy, which we call conflict resolution.
And I love this quote because it really gets to the heart of the most important mindset shift here. In this world, the local database is king. It is the single source of truth for what the user sees. The app doesn't need to ask the internet for permission to show you your own data. It just shows you what it has locally, right now.
Okay, but what happens when data clashes? I mean, imagine you edit a note offline, right? But at the same time, your collaborator edits the same note online. Now what? That's a conflict. So teams solve this in different ways. Sometimes the last change made is the one that sticks. That's called last right wins. Other times, the server always gets the final say. It's a really critical design decision you have to make.
Now, as amazing as all this sounds, it's not a silver bullet. It comes with its own set of strategies and, maybe more importantly, some pretty significant challenges. So let's get a reality check on what it really takes to build this way.
See, it's definitely not a one-size-fits-all kind of deal. A news app, for example, might just use a cache-first strategy to show you recent articles. A messaging app like WhatsApp, that's got to be fully local first. And something like an e-commerce app could use a hybrid model. It keeps your cart offline, but still needs a connection to load its huge products catalog. You pick the strategy that fits the job.
And here we go, the pitfalls. You got to be honest about these. This architecture, it's more complex. There's no getting around it. Your app size is going to get bigger, managing those data conflicts can turn into a serious headache, and you have to worry about the phone's operating system killing your background sync process. So yeah, this is not the easy path, which brings up a really crucial question.
Given all those challenges, the big question becomes, should you use it? Let's take a look at the deciding factors to help you figure out if this powerful architecture is actually right for your next project.
Well, the answer really comes down to your user and what they need. If you're building a productivity tool where a seamless experience is everything, or if your users are often in places with spotty internet, then yes, absolutely go for it. But for a simple admin dashboard that's always going to be used on a stable office connection, it's probably overkill.
Okay, here's a pro tip for all the developers watching right now.
Seriously, understanding this stuff is a huge career booster. In a system design interview, being able to architect an offline-first system is what separates a good answer from a great one. It shows you're focused not just on code, but on user experience and resilience. That's senior-level thinking.
So if an interview hits you with, design an app like WhatsApp, bam, this is your playbook. You start by declaring the local database as the source of truth. Then you add a background sync worker. That's our sync engine. Next, you implement what's called optimistic UI updates. That just means the app pretends an action, like sending a message, will succeed later, so it shows it is sent instantly to feel fast. Finally, you define your rules for handling data conflicts. That's the path to a rock-solid answer.
This table right here, it sums up the whole trade-off perfectly. I mean, look at the columns. You can see offline first demands higher complexity up front, for sure. But in return, you get a seamless user experience and, get this, an app that can actually be highly scalable. It's a trade-off between that initial effort and long-term quality.
All right, if you remember just one single thing from this entire explainer, please let it be this. The crucial point is that the user interface, what the user actually sees and touches, never ever waits for the internet. That is the fundamental promise of offline-first architecture.
And that kind of leaves us with one final thought, right? As our expectations for fast, reliable apps just keep going up, and as we connect from more places than ever before, is this approach no longer just a niche technique, but the new default standard for building high-quality applications? What do you think?